Let's be real for a second. Have you ever built something that worked, perfectly for like 10 users, only to watch it just completely fall apart when you hit 1,000? It's a classic story in software, right? A journey from this simple, beautiful idea into a complex, tangled mess. Well, today we're diving right into one of those stories, and honestly, the elegant solution that brought some much needed order back to the chaos. So, where does this kind of chaos usually start? Well, it almost always starts with the users. Meet Jake. For him, a notification that's even a few seconds late isn't just a minor annoyance. No, it's a missed opportunity. It's actual money lost. The system he's relying on is failing at its number one job, being on time. And it's not just about speed. Over here, we have Maria, and she's dealing with a totally different problem: reliability. She's getting spammed with the same information over and over, which is just cluttering up her workflow, and you can imagine it's totally eroding her trust in the system. So the problem isn't just one thing. The whole system is becoming unpredictable. And then there's Tom. For an algorithmic trader, let me tell you, a 5-minute delay might as well be a 5-day delay. It's completely useless. The system is fundamentally broken for its most important users. So what in the world is happening behind the scenes to cause all this frustration? This brings us to Sarah. She's the founder of Stock Alert. And yeah, she's feeling the heat from Jake, Maria, and Tom. Her dream of a simple, helpful tool is quickly turning into a full-blown technical nightmare, all because of this nasty little thing called tightly coupled code. And here it is, the heart of the problem. This one giant function, update stock price. Every single time a price changed, this function had the massive, overwhelming responsibility of telling everyone: the email service, the SMS service, the logger, the analytics dashboard, you name it. And what if you want to add a new feature? Well, you have to dive back into this monster function, add another line of code, and just pray you don't break everything else in the process. And you can just feel Sarah's frustration here, right? This is not sustainable. The code is brittle, it's a nightmare to test, and there's no way it can scale. Every tiny change feels like you're performing open heart surgery on the entire application. It's a total mess. Just when things are looking totally hopeless, a mentor appears. Dr. Rodriguez takes one look at Sarah's problem and immediately knows what's going on. It's a classic one-to-many dependency issue. And lucky for Sarah, there's a classic pattern designed to solve exactly this kind of problem. And here it is, the observer pattern. It's such a beautifully simple idea. Instead of one object being responsible for telling everyone else what happened, it just raises a flag. It just says, hey, for anyone who cares, I've changed. Then any other object that's interested can see that flag and react all on its own. Think of it this way. It's the difference between a town crier running around yelling at specific people and a radio station just broadcasting a signal for anyone with a radio to tune into. So much cleaner. So how does it actually work? Well, it's really just got 4 core pieces. You have a subject, that's the thing being watched, and you have the observers, the things doing a watching. They communicate through a very simple contract. When the subject changes, it just notifies any observer that has subscribed by calling a standard update method. It's a really clean separation of roles, and that's what makes the magic happen. Okay, enough theory. Let's put this into practice. It's time for Sarah to go in and rewire Stock Alert, and for us to see this transformation for ourselves. And wow, this slide just says it all, doesn't it? On the left, you've got the before, that long, fragile, scary list of commands. The stock monitor has to know about every single service. But on the right, the after, it's beautiful. Just one line. The monitor updates the price and sends out a single notification. It has no clue who's listening. Could be 5 services, could be 1,000. The thing is, it just doesn't care. Now that is the magic of decoupling. What this does is it creates this fundamental shift in responsibility. The stock price monitor is no longer a micromanager barking orders at everyone. It's now a broadcaster. Its only job is to announce, hey, the state has changed. The individual services, like email or SMS, they're now responsible for themselves. They just subscribe to the broadcast and decide for themselves how to react when a new announcement comes in. But the observer pattern, it's not just about cleaning up messy code. It's really the foundation for building these massive, scalable, event-driven systems that can handle just an incredible amount of volume. For example, you can make your notifications way smarter. Instead of just yelling, the price changed for everything, the system can send out different types of events. So let's say a massive 10% price swing happens. That triggers a very specific major price change event.
This is fantastic because now only the observers who really care about big moves, like Tom, our algorithmic trader, need to react immediately. It makes the whole system so much more efficient.
You also have flexibility in how the data gets shared. With the push model, the subject just sends all the data it has in the update. It's simple, but it can be pretty inefficient. The alternative is the pull model. Here, the subject just sends a quick heads up, like, hey, something changed. Then it's up to the observer to pull only the specific data it needs. This is way more flexible and, in a lot of cases, a lot more efficient. Once you really understand this pattern, you're going to start seeing it absolutely everywhere. And I'm not kidding. This isn't some obscure academic concept. It is a fundamental building block of so much modern software. In fact, you've probably interacted with this pattern thousands of times today. When you click a button on a website, that's a subject firing an event, and some JavaScript code is the observer listening for it. When you get a new post in your social media feed, that's the result of an observer pattern. From the MVC frameworks that power most web apps to the microservices that run the cloud, this pattern is the secret sauce for creating responsive, decoupled systems. But like any powerful tool, you've got to use it right. The golden rule is loose coupling. The subject should never, ever know the specific details of its observers. And just as important, you have to clean up after yourself. Forgetting to remove observers when they're no longer needed is a surefire way to create memory leaks that will slowly, painfully grind your application to a halt. And those memory leaks are just one of the common pitfalls. You also have to watch out for some really weird unintended consequences, like notification storms. These are basically infinite loops of updates that can bring your system down. And you have to be mindful of performance. If too many observers all try to react at once, you can create your own bottleneck, which kind of defeats the whole purpose of a responsive system in the first place. Which brings us back to Sarah. Fast forward 2 years, and she's no longer fighting her code. She's up on stage at a major conference, an expert in reactive systems. Her journey taught her this core philosophy. Great systems don't force things to happen. They create an environment where components can react automatically, and most importantly, independently. So the next time you find yourself in one of those monolithic nightmares, with one part of your system all tangled up in the business of another, ask yourself this question. Maybe, just maybe, the elegant simplicity of a subject and its observers is exactly what you need to find some clarity in all that chaos.